Messaging Systems with MassTransit with Chris Patterson.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and run your software with confidence in Azure, all while using everything the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. They are hiring architects and .NET engineers who would like a path to become an architect. So you can go to clearmeasure.com/careers. And finally, be sure to check out the new video shows. Our guest today on the show is Chris Patterson, coming back for another interview, and he is the principal architect at McKesson, the oldest and largest healthcare company in the nation. He's responsible for architecture supporting applications and services that enable distributed technology solutions around the globe. He's also an active open source community contributor. He's created many projects like MassTransit, which we're talking about today. It's a distributed application framework for .NET. He's also a regular conference speaker. He likes to share his knowledge and experience with developers around the world. And he is a longtime recipient of the Microsoft MVP Award for his contributions to the software development community. Chris, welcome back to the show. How are you, sir?
I'm doing well. How are you, Jeffrey?
I'm great. It's
good to be back.
Day. Yeah, absolutely. Now, some of the listeners might have heard your previous interview or seen you speak, because you've done a ton of speaking, publishing. Tons of people use your projects, use MassTransit, and we're going to dive in that today. But for those of you who, for those listeners who haven't become familiar with you, can you give us a little background? What are the high points in your career that have kind of led up to what you're focusing on today?
That's a good question. Let me see. I've been a lifetime software developer. I think the first application I wrote was a game on an Apple IIe. So that gives you some perspective of how long I've been doing this, because the Apple IIe, I don't think it's existed for longer than I'd care to mention. But when I first started out my major professional career, I was building a lot of distributed systems. And back then it was NetBIOS and IPX. I mean, Novell networks were the rage. And so my start in network communication and distributed applications was early on, and it's continued throughout my career. I'd say some of the biggest points were, jumping into kind of the SOA 1.0 world and then recognizing the challenges of that. And then, I guess it was probably like 14 or 15 years ago, getting together with the first alt.NET meeting down there in Austin and kind of meeting a lot of the people and getting a completely different perspective than the, canonical out of the book, this is how you build software using Microsoft tools and technologies. It was an eye-opening thing and met a lot of cool people. I think I remember sitting in I want to say we were sitting in a Champions down at the Holiday Inn, and you were hacking away with either Goo or Hanselman on like the first bits of ASP.NET MVC. And you were like, this is going to be awesome. This is so much better than monorail.
Yeah, well, it was. Actually, I can lay unofficial claim to the first public customer site using ASP.NET MVC in the fall of 2007, because
there you go.
Because Scott Guthrie, he basically gave the first public demo at that. I think it was October or September 2007, and I went to dinner with him, and he gave me the thumb drive with his prototype bits on it.
Yeah. That was a long time ago, but think about it. Back then, you'd walk into a room full of people and say, okay, so who's using dependency injection? And they'd be like, that's what again?
Crickets, yeah. Let me just touch on that just for the listeners, because that was ancient history. But, alt.NET, the name may surface every now and then. And actually, you can still go to Yahoo groups. I think there's still the AltNet Conf Yahoo group, ALTNETCONF Yahoo group. Yeah, it's still there. And it was this group of people, and it started around test-driven development and extreme programming practices and inversion of control was one of those big topics. But it was basically a group of people that said, wait a minute, the industry, there's a different way of thinking about just regular programming. And then there's the Microsoft documentation of the time. And at the time, Microsoft had two manual software testers for every one developer, but that was kind of divorced from the industry because the Agile movement, you had Scrum, but then you also had extreme programming, which was big on engineering practices, which included TDD and different ways to do object-oriented programming. And so alt.NET became kind of like the community brand of the movement to say, hey, I think that there's a better way to do this with C#, with .NET.
Yeah, it was definitely an enlightening time. And I mean, the flavor of the month at that time was Ruby on Rails and RSpec and all the cool unit testing tools. And, like you said, TDD and just the better practices of building software. And I think that meeting where, Microsoft was willing to sit down and not just sit down, but share the bits. And like, we are thinking of a better way to do this. Web forms isn't the only way. View state doesn't have to, live forever. And yeah, it's, you look at the Microsoft of today where things like Microsoft extensions, dependency injection and configuration and options and all of these things are just de facto out of the box standards now. Yeah. And think, now it's like a super compelling, super fast, super powerful platform that if you look at the Tech Empower benchmarks, we're in like the top 6, which is good company to be in. So yeah, there isn't any reason to say, oh, .NET is another thing. The fact that it's open source, it runs on any platform, it runs on Linux. I haven't developed on a Windows machine in 6 years, and I do .NET every day. So to be able to say that and, not have to use VMs or anything like that it's a pretty compelling story in how much .NET has evolved from the Windows only Visual Studio era. So
let's do a quick aside, just because we talked about this with a few other guests. All right, now is it Mac? That's your primary workstation now?
Yeah,
give us a quick rundown of your stack. You're using .NET. And you're on Mac. Give us a quick rundown of what your stack is, just soup to nuts.
My stack, soup to nuts, is I do all my work on a Mac Pro. I've run JetBrains Rider for my IDE. I'm always using the .NET SDK, whether it's 3.1, 5.0, or 6. I use Docker locally to run almost everything in Docker. I don't do my builds in Docker, but I can. And the projects that I run, GitHub is my preferred stack. GitHub Actions is my preferred CI/CD. I deploy everything to NuGet or npm.js. And yeah, I don't use any other tools. I mean, Rider and .NET on the Mac are where I've been for years and years.
Okay.
I don't have Mono installed on my Mac at all. That's how far we've come from the era of having to use Mono to run .NET on a Mac.
Yeah, right. Which kind of Xamarin kind of came from that, but also .NET Core came from that Mono project, really.
Yeah, a lot of that came from it. I mean, it was a ground up rewrite. Roslyn really made a lot of difference. But and now they have .NET 6, I think, even has native ARM support. So if you're on a Mac that has a new M1 chip, you're getting native compilation at ARM64 instructions, which that's cool. Yeah. That's like, you can't even get good ARM support on Windows, and you have it in Mac with .NET 6. So that's pretty awesome.
Nice. And for environments, what are you hosted? Are you 100% cloud, serverless, VMs?
It really depends. I mean, most of the stuff that I build and test and deploy is up on Azure Kubernetes or Google Kubernetes Engine. I have some stuff on Elastic Container Service in Amazon for situations that run on Amazon. But I'm deploying most things to Kubernetes these days. I haven't used any of the PaaS services on Azure, like Azure, I think they're called ACEs, Azure Service Environments or things like that. Haven't used any of that. I don't like serverless. I don't like Azure Functions. I don't like Google Cloud Run. I don't like any of these serverless, deploy 1,000 applications to get one application up running thing. That, to me, that's just an operational nightmare, and I hope it all ends soon. But I'm not a big fan.
Okay, so you're on AKS, Azure Kubernetes Service. That's
AKS is what I prefer. AKS or GKE, they both work the same. kubectl is kubectl from the command line. It doesn't really matter. When you're deploying from GitHub Actions, it really doesn't matter which one you're going to. It's just which secrets and targets you have configured. So.
Gotcha. Okay. Wasn't it interesting that Microsoft used to be Windows and Windows used to be Microsoft. Now Microsoft is everywhere. Like you mentioned NPM. Well, that's Microsoft. You mentioned GitHub. Well, that's Microsoft.
They bought everything. It's like pretty crazy.
Awesome. Well, let's get into mass transit and messaging. And just before we move on, can you give us a quick rundown? What the heck is mass transit? It's like what you use in downtown in a big city, you get somewhere.
Well, it's a bus, and you take it from A to B. I've been asked many times how to describe mass transit, and there's always this, what is your 30-second elevator speech? And, if I'm talking to a developer who has an understanding of like different languages and different tool sets, I can say it's kind of like the JMS of .NET, because that's one thing .NET has never had is like an abstraction over messaging. And Java has had JMS, Java Message Service, which provides kind of a loosely lowest common denominator API of messaging for Java applications, regardless of transport. So mass transit is an abstraction. It sits on top of message transports such as RabbitMQ or Azure Service Bus or even Amazon SQS, and even in some cases ActiveMQ. And if you're coming from a .NET background, it's kind of like ASP.NET for messaging. You create consumers, which are very much in line with what a controller would be. The consumers can handle different message types, which translate to like action methods. And you're able to have that same kind of programming experience where you create consumers, you register them on the bus configuration, and mass transit handles all the work of like setting up the subscriptions and creating the queues and creating topics and routing messages and delivering them to your consumers. And much like ASP.NET, when a message arrives on a queue, you aren't reading it. You don't have to deal with any transport work. Mass Transit's a Hollywood principle framework. We'll call you. So when a message arrives on the queue, Mass Transit gets that message, converts it to a type, a .NET type. So you only have to deal with types, just like you deal like with a model in a controller action. And it creates an instance of your consumer from the container, letting you have all the dependencies you need, things like that. Calls a method on your consumer to let you consume that message. From that method, you can produce other messages. You can go talk to databases. You can really do whatever you want. You can respond, all of those types of things. And then once you're done, Mass Transit acknowledges the messages on the transport, which moves it out of the queue and handles that whole life cycle for you. So it really makes it easy to build, activate me applications, similar like ASP.NET, but against any message transport. And the nice thing about Mass Transit is you can write it once. And this is a use case I was talking to with someone yesterday on it, and it's so common. Well, I want to test locally. Okay, well, Mass Transit has an in-memory transport, so you can just kind of test unit tests. And for all the unit tests you write, it has a lot of extensive test harness support. But they're like, no, I really want to test with a broker. So people will test locally with RabbitMQ. And then when they deploy to like Azure Kubernetes or just app service, whatever, they'll actually run their application on Azure Service Bus. So, and they don't have to rewrite any of the code. It's just two different settings, whether you're configuring the bus for RabbitMQ or Azure Service Bus. Mass Transit handles all the translations between RabbitMQ exchanges versus Azure Service Bus topics. Whereas if you're going to Amazon, it's SNS topics that then send messages to SQS. So it's really made it easy to, disconnect yourself from the transport implementation and focus purely on writing the logic. And that's like the base functionality. And there's a lot more that we could go into that it has, but that's kind of like the base set of features that really provides the value that a lot of people see.
Okay. Now, just a quick digression. Why would you choose in production Rabbit versus the traditional Azure queues versus the Azure Service Bus topics? What's the thought process there?
It's an interesting question. The most widely used transport with Mass Transit is RabbitMQ, and for good reason. It's a solid message broker. You can run it in a container. You can run it through like Cloud AMQP. Amazon has hosted RabbitMQ now. So there really are a lot of opportunities to take advantage of RabbitMQ. And I think Cloud AMQP even hosts in Azure and GCP now through the marketplace. So you can actually just run it in your subscription and install it through the marketplace and be billed through your Azure credits. So it's a pretty cool setup. Azure Service Bus is a full-featured message broker. It has a lot of the capabilities that you would expect. It has decent throughput. I think in the data center with a fairly large premium plan, I was getting like 6,000 messages a second, which is pretty decent. RabbitMQ by comparison on my local machine, I get like 18,000 a second. So just again, but that's a pretty contrived case of no actual network latency and everything. So,
well, isn't it funny that our engineering workstations actually have more power than the run-of-the-mill hosted server?
Well, I mean, a laptop is different than a Mac Pro with 192 gig of RAM, so it's a little different things. But
you say 192?
Yeah.
Here I am like a chump sitting at 64.
Hey, 64 is awesome. And I admit I have a lot of free space, but I got a lot of RAM disk or whatever it is. I don't know how Mac OS does it. It's just, if it fits, I'm going to put RAM in it. I can't have empty slots on a motherboard. What's that?
You can't have it. All right. So RabbitMQ, is there, okay, if you're going cloud native, and if you're all in on Azure, is there a compelling reason to grab RabbitMQ versus just say, you know what, Azure, just do it for me, Azure Service Bus?
Yeah, like I said, you can pick either or. I mean, now that Cloud AMQP has marketplace things and the pricing is competitive, it's just whatever messaging patterns you need. I mean, if you're just doing basic messaging and your volume isn't super high and you're not looking to take advantage of transport-specific capabilities, which MassTransit makes really easy, by the way, because of the way it's architected. But if you're just doing messaging, publishing, and doing just some loose coupling within your applications, either will work. I mean, you can, and a lot of people like the ease of just provisioning Azure Service Bus and letting it go. And we've recently upgraded I won't say we, someone who may have a blue badge submitted a pull request to upgrade MassTransit to the latest SDK of Azure. So it's all on the latest bits now. And that was brought in, and I think that was started with version 7.3. And that's, there's a lot of reliability and transient issues with Azure Service Bus. You can get throttled quickly depending on your pricing plan because they do a lot of rate limits and stuff like that. So it really just depends on cost and message volume and what your expertise of your operations staff are. Yeah, there's really no compelling reason to choose one or the other. It's just whatever you're comfortable with. So,
okay. Now let's back up to maybe some of the assumptions. We've talked about RabbitMQ, Azure Service Bus queues. Those are all asynchronous transports where you can just send something over, but you might not get anything back in 10 milliseconds or 10 seconds or 10 minutes, depending on what's going on on the other end of the wire. And so tons of people just say, look, I'm just going to use web services. It's easy. I just use web services for everything. And you see a lot of these applications, even the SPA applications, call a web service to something else. Oh, I need to integrate. Let me call a web service. And you have multiple components that are linked by web services. And sometimes it gets slow on the user's end. They click a button and it's like, what's it doing? It's spinning. Why isn't it coming back? And, on the back end, it's like web service versus web service. I think that original healthcare.gov project, it was revealed that there was a lot of web service integration with like even back end mainframes and whatnot. So is MassTransit, first of all, is MassTransit just for the asynchronous, or is it for any way that a program could talk to another program?
So let's tackle that a little bit deeper. So when we talk about the nesting of RPC or, web service, or basically let's just call it request response. Whenever you make a call and expect a response, and then your service calls two services and those two services call two services and so on and so on. Yeah, you get this nasty web of nested RPC calls across, what originally was just an API endpoint on an ASP.NET website. So the challenge that creates is when something times out or when something breaks or when something fails, what is the state of the system? I mean, do you really know at that point? I mean, did some of them succeed? Did some of them fail? How do you handle retry? How do you handle timeout? Say you have a front-end API that's actually creating a headless background cart in, say, a Shopify endpoint. So not only are you within your application, but your application has to make API calls out to external systems. So if a customer on your front end app in your Angular app hits an API endpoint and says, hey, I want to add this to my cart, or I want to check out even, that's the crazy one. I want to check out. So you go and you try to take that draft order in Shopify and commit that order. and it times out because you're rate limited by Shopify because you're on the cheapo plan because you sell 3 t-shirts a month, whatever, then how do you propagate that error back to the API to then show it in the UI, but then maybe it did go through and it was just delayed? So do you get 2 t-shirts? These are the problems that come up with synchronous, because even though they're web services across, multiple endpoints, they're all request response. So they're all waiting for that response. And so that creates a lot of nasty problems. Whereas if they just said in your front end, I'm going to call this API to say, submit the order. And let's say we just wrote that message to a queue using MassTransit. Well, now you have a backend service that can be up or down based on the availability of downstream services, and say, okay, well, I'm going to submit that order to the Shopify API. Okay, it timed out. Okay, well, MassTransit, besides just being an abstraction on top of message queues, has a large assortment of middleware components that you can use for things like retry, redelivery, fault handling, circuit breakers and kill switches and all these things to say, oh, Shopify's down. Well, I'm just going to stop reading from the queue because I don't want to just write all these messages to the error queue. I don't want to just cycle my queue for the sake of generating revenue for Azure by reading and writing messages. So I'll just stop my endpoint for a minute, try back up, just kind of like the inverse of a circuit breaker pattern, but doing it so that I'm not reading the queue and then calling a remote system that just fails because it isn't available. So it's a smart back off. But the front end API, it's already done. It's done that async fire and forget. It said, okay, well, I'm going to submit the order. Done. Okay, great. The system has the message. It will eventually process it and then update the order status in whatever state you're tracking for that order in your own system. So MassTransit can do it both the asynchronous, but it can also do the request response type patterns, because you can do those over messaging. There isn't any reason not to. And I think one of the things people think about is, oh, well, messaging has to be slower than HTTP. Well, not really. I mean, when you look at the numbers and look at the benchmarks, I mean, for a typical application, especially one that has to wait, say, 8 milliseconds for Postgres to respond with the results of a query to, materialize a cart or something like that, the overhead of either HTTP or an AMQP connection to RabbitMQ, which is always on and connected when the way MassTransit uses it, is about the same. It's a wash. I mean, you might be able to synthetically get a little bit more via HTTP because, let's face it, the ASP.NET team with Kestrel has crushed it. That thing is so fast and so heavily optimized that it isn't the bottleneck, but it never usually is. It's usually that remote call to the Shopify that's running in the West data center and you're running in the East data center, which that's 30 milliseconds right there. So it's never really the transport for request response that's the problem. It's just the complexity that HTTP introduces by having a whole bunch of services that call a whole bunch of other services, all creating these synchronous calls across the network to these other services, expecting a response. So yeah, it's MassTransit can be used for either. MassTransit can send a message and wait for the response, and it does all the coordination for you. So you get a very HTTP client-like experience with the request client that's part of MassTransit. So you can just send a message and say, okay, well, I'm going to wait 30 seconds for a response. If I don't get it, I'll time out. But you have to recognize that message may have been received and processed, and you just didn't wait long enough for the response. So, it's just, It gives you flexibility in how you want to handle it.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
I think that one program calling another program is only expanding from a architecture that's just growing and growing. There was a time when teams tried to just make single process applications, just to avoid hopping over that boundary. Built into .NET as service workers. You can have a service worker that's part of the same process that's doing things, but then, that doesn't work well with a web farm because then you have to manage, how many, service workers. But But my observation, I want you to kind of, if you think that I'm thinking about this right, is you've got the request response versus asynchronous queue it up aspect, but then you also have the situation of objects on both sides of the wire and serialization formats, and just the possibility of explosion of types that are just data transfer objects. And so, but if you control both ends of the wire and you got some web services, then you got some connections through SignalR, you got some through Azure Service Bus. Have you seen a way to consolidate the serialization and the DTO types so that you don't have to have specific types all over the place just because you happen to be going over a different channel?
Yeah, I mean it's an interesting thing to think about. So when you talk about DTOs and message type, what you're really alluding to is there's a contract between a client and a server. When I make a call to, and I'm not even going to talk about .NET, when I make a call to Shopify to create a draft order, there is a loosely defined JSON document that I have to send them.
Yeah.
And that fits really nicely in the whole untyped NPM world. But in the world of .NET, where we love our types and we take advantage of static typing and type checking and verification and all the great things that come with a statically typed language, we have to create some sort of defined contract in those types. And I'm a strong believer in code first. Everything in MassTransit is code first. There is no doodleware. There is no, we'll go create this XML document or JSON document, and then we'll cross-compile that into code for you. If you want that, go get some 20-year-old enterprise service bus tool and pay a ton of money for it and hope it works. Don't forget to renew your support contract, though. So MassTransit is very code first. It's very developer focused. So when you define a message contract for a service, you're just defining a type. And I mean, I previously used interfaces. With .NET 5 now, it's all about records and init-only properties, and it's pretty and it's nice, and you can use with to expand them. And records are great. I love records. Mm-hmm. But you're defining those two message types. And when you think about the ownership of types, if I have a service, I'm going to say I accept A, and I'm going to return B. And these are the types of A and B. And I can evolve those types over time. And there's some good guidance on the MassTransit site about how to add, you can add a nullable property, but you need to handle the fact that certain clients may not provide that nullable property for you because it is being serialized and deserialized, and nullable properties can just come back as empty. Whereas if a downstream client serialized that with an older version of the contract that didn't have that property, it just isn't in the JSON. And you're like, okay, no big deal. I'll just give it the default null value and we'll process it appropriately. So there's a lot of ways to evolve those contracts, but there needs to be within a large system ownership of those contracts. Like, this is my service. I add an item to a cart, and this is the contract to add that item to the cart. And I will produce an event that the item was added to the cart with this specification, these properties and this type name. But those are my types. I own them. And I don't believe that contracts like that should be shared across services, because that creates, an unclarity of ownership. And then you end up with optional properties that are only used by one of the different implementations. And it just kind of creates a mess. So yeah, there are definitely types involved, and they're usually very clear. The trick is, how do you document those? And that's always been the hard question, is like, okay, well, we have 35 services in our organization, and they take, a variety of different commands that they process. What do those look like? Where do we inventory those? Where do we have like our API documentation for message-based services? And if we ever get a good answer for that, I'll let you know, because we still don't have it. There's no good answer. I mean, it's kind of like the enterprise microservice directory of, okay, these are all the JSON types supported by our services, and here's the URIs. And, there've been a lot of attempts to try to solve that problem. It's a hard problem to create like an enterprise service directory catalog.
Well, when you think about just web services with web API, and then you've got Swagger, I mean, there are some easy ways to say, let me just see what I can call and how to call it and what is the contract.
Yeah, Swagger is great. And the Swagger UI, where you can just like simulate calls, is awesome. But then how do you combine that into a global thing without knowing the Swagger endpoint to begin with? That's the trick.
Yeah. What's the directory? Isn't it interesting? This is ancient history again, but back in 2001, 2002 WSDL,
Yeah.
WSDL, Web Service Description Language. That was an attempt to solve the problem of discoverability. And we still haven't solved that problem
I
as an
mean, Open
industry.
API 3, the Open API spec is basically the new WSDL for, JSON loosely coupled web services.
Yeah.
But yeah, it's again, it's how do you get that enterprise catalog of services, and do you really need it? I mean, unless you're publishing services, and I mean, if you go to Shopify, they have their API documentation. You go to Braintree, they have their API docs. Everybody has their own API docs and their own formats, and you can usually pull down like a RAML or an Open API spec and load it into your client generator. But again, that's cart before the horse. I'm going to take some JSON file and write code from it, and I'm just not a huge fan of that.
Now, as a service owner, you think about the architecture of it. Isn't it fair to ask whether or not you want your server endpoints to be directly called by your customers, or whether you want to provide them with an API that then lets some of your code run in their process and have your code be responsible for hopping the wire? What are your thoughts on that?
See, that we actually talked about that a couple of days ago. Someone was like, how do I set up security so that I can have all of my remote devices connect directly to Azure Service Bus and submit messages? And I'm thinking in my head, why would you do that? Why would you not just have API endpoints that are running up in a nice global, directory load balancer thing in Azure, and have your mobile devices talk to that API and leave messaging for the internal network, internal application dispatch? And I still haven't, I recognize that some people think it would be cool. They're like, well, I own the application on the remote device. And believe it or not, MassTransit actually runs on iOS. If you compile it down using whatever that tool is, I think that's the Xamarin stuff that compiles down to a native iOS app. And you can run MassTransit on like an iPad application that's connecting back up to like RabbitMQ or Azure. So I was surprised that worked. I actually think we actually had to make some type changes to get it to fully work. But yeah. But then the question is, well, what happens when the network isn't available? When that UPS truck goes under a bridge and it's trying to update its location, from the iPad application, how does that connect? So.
No, it's totally true. But even simple security is one thing, but even as simple as throttling, like if you have people calling your service and it's a web server endpoint, or maybe even if you do expose a queue or some sort, and back in the day, people would say, here's your directory in our FTP server, just go ahead and drop files. You really don't control that, but my thought in some instances, if I can write some code that you are actually going to run in your process on your device, then it gives me a surface area to put some logic where I could say, you know what? I returned that exact answer from my side really, really quickly ago. I'm going to have some default caching right there on the client, or whatever logic may seem appropriate.
Yeah, I definitely see, there's a lot of tools out there that have said, oh, well, here's our client libraries for these languages. The trick is then, but if you own it, like if you own the end user device and it's always going to be, say, iOS or Android or a Windows, platform or something like that, or even if it's just running on, Atom or Electron or something like that, it's, if you can control the experience and provide a better consistent programming model versus just saying these are our API endpoints, there's certainly cases where that makes sense. Again, it's just the maintenance of, if I was providing a React plugin to call our API that gives a better experience than just trying to figure out our APIs natively, I would totally publish that NPM and use it in different cases, because I think it would make sense.
Right.
It's just about making, the hardest thing about communicating to developers is to get them in the same mindset and to get them to figure out how your API should be called the way you thought about it being called versus the way they see it. Because a lot of times it's different. People just come from a different background and different experience. And when they approach an API, they don't think about it the way you thought about it when you wrote it.
Yeah.
So just, following some of the consistent paradigms of the language that you're in, like if you're creating a Vue.js component or a React component, making it work with the the idiomatic behaviors of other components within that UI framework. But behind the scenes, you're doing your connection to AMQP and writing directly to RabbitMQ. Rock on. If you can make it easier for a developer to adapt their solution to use your service, that's a win for everybody.
Mm-hmm. Yeah. It seems like you use the term API, application programming interface. It seems like that term has been, in the minds of a lot of people, used as a synonym for HTTP web service. When
it sure feels like it with the API economy.
Yeah, maybe the long timers, we say app and we like, okay, you can have APIs of all kinds. Heck, an API is just a method of a class. It could call in process. It's anything. It's a way to call some type of function entry point of a program, not just a web service through TCP, hosted on a web server. But are we ever going to recover that API? Do we need another term, or do we need to reinforce how many types of APIs there can be?
Yeah, that's, if you think about it, when in one of the early talks I did about MassTransit, about how messaging is different than an in-process method call, you're spelling it out for people. A method call has 5 parameters. Okay, well, I'm going to pass those 5 parameters. Well, that's a lot of parameters. Let's just make a class and pass all those parameters in a class so that we can make it more efficient. So it uses less call stack. And then it's like, okay, so now we have a method that takes a class. Okay, well, here's a MassTransit consumer. It has a method called consume. It takes a class. You've just moved to where you can be run in a messaging framework and accept a message from anywhere, not just an in-process method call. I mean, they're all technically, it's an API, it's a interface standard, but yeah, it's all just a bag of properties that you throw around, the process memory, the network, whatever, so that some method knows the incoming arguments of how to behave.
Well, as we close up here, we should probably tackle a problem that everybody has with messaging, and if people are going to try it fresh because of this conversation, they're going to encounter it. And when something's wrong with the processor and just exceptions happen, messages are just going to dead letter. Talk about that process and what the heck do you do? How do you prevent it? How do you recover? The whole concept.
Yeah. So you mean systems don't always work perfectly,
right.
As they're designed? Yeah, it's definitely one of the things that comes up. When a consumer throws an exception in MassTransit, after the retries are exhausted and the redelivery attempts limit is reached, MassTransit's going to either move it to an error queue, or in Azure you can configure it to use the built-in dead letter queue of Azure. Managing of those is tricky because you have, your operations team needs to manage that. They need to either be tracing the logs or monitoring events produced by MassTransit that say, oh, this exception occurred. Your consumer blew up. And as I mentioned before, there is middleware that can try to catch those and, limit the bleeding, so to speak. So you aren't just, burning through 10,000 orders when Shopify is down and throwing them all into the error queue, creating work for your operations team to have to move them back to the actual queue. But that's ultimately what it comes down to, is if your system does just go belly up and dumps, 10,000 messages into the error queue, typically your team is then stuck with, how do I move those back into the processing queue once things are ready? Either I've fixed the code or the downstream service is now available. The management tools for that are not great. I will say that they may be getting better. There may be some certain projects underway to create SaaS-based services to connect to your brokers and do some operational management tooling around, the different queues and stuff like that. And there may be more to come on that by the end of the year. But I do know people that are well underway and building some of these operational tool sets to run on top, and not just for MassTransit, but any message-based transport, whether it's Azure, RabbitMQ, whatever, and whether you're using MassTransit or other things like Rebus or NService Bus or other tools like that. But having a nice SaaS platform that you could put in place to monitor and run your applications, and just put some automatic recovery stuff in place, like, oh, well, if I see this error this many times, maybe I want to do something with it. There is work happening in the space, because I think, Azure DevOps podcast. Well, if you're really doing DevOps, your developers are feeling that pain. And whether it's a Jira ticket back to the op team, back to the engineering team that says, "Hey, what's all this stuff in this error queue? What do I do?" You can't just write a playbook if you don't have the tools to do the right thing. And in each, RabbitMQ has a shovel. I think you can use the Azure portal to move messages from one queue to another now. I think they put some limited stuff in place there. But yeah, the experience isn't great. And, there's better ways to go at it. And I think we've identified a few of them just based on supporting mass transit. It's how do we get that better? But yeah, it is a problem. But the nice thing is if you were in an RPC world, all of your end users would be getting 500 exceptions on their API calls, whereas in the messaging world, you have their order, you're going to process it eventually once the back-end fulfillment systems are fixed and be able to brought back up online. So it's the benefit of that is that you have the asynchronous processing, you have the message, you've acknowledged their request. You'll just be able to process it again once you get your systems recovered.
Yeah, that's a good point. With web services, if something bad happens, your user is expected to take a compensating action.
Right.
And so if there's no way that the user can take a compensating action besides call tech support or please report this issue, then
check their credit card statement and see if they were billed.
Right. On the corollary, if we take a customer's order and we just take it, we do form validation on the wrong side of the wire. Well, now our operational team is like, I don't have an address for this order. And so it's who can actually fix certain type of errors. And those are important decisions. All right. Well, Chris, thank you. As we come to the end of the show, everything we talked about, we'll make sure to include those in the show notes. Is there any particular URL or resource that you would point the listeners to if they kind of have their interest peaked and they want to dig in right away?
The first place to go is just search for MassTransit Project. MassTransit-project.com is the main website with the docs. From there, you'll find everything from getting started, the repos, sample apps. There's links to the Discord channel that, I seem to be on way more than I should be, because there was a comment the other day. It's like, wow, every time I ask a question, you respond in like 30 seconds. And I'm like, does that mean I don't have a life or that I just live the code? I'm not exactly sure what to think. But yeah, there's plenty of resources out there. Just search for Mass Transit Project, MT Proj, or just Fatboy G, and you'll find it. I mean, Google's pretty smart. So
cool. And how much does it cost?
Mass Transit is a free open source. There is no charge to use it, and there never will be.
Awesome. Well, hey, Chris, thanks so much for coming on the show. I appreciate it.
Yep. Thanks for having me.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.